Okay, this is where this class really starts to get fun because we're going to do some numbers. As you guys know, psychology is a science and we need numbers so we can do statistics. That was a question in your survey says assignment. Why do we have to take answers to our survey that were words like I'm male or I'm female or yes or no and convert it into a number? Because that's how we do statistics. Also, in your design and experiment, some of you guys, for your dependent variable, you were doing a study where you said, well, I'll just ask them how they feel at the end. Don't do that, because you ask people an open-ended question like that, you start yakking. And what's your data? A bunch of words, like paragraphs of what they said? What am I going to do with that? Actually, some researchers love that, and it's called qualitative data. And it's done in qualitative research designs. And they deal with everybody's thoughts, and when they come out spewing in interviews or they draw pictures and they do something with it. We're actually not doing that kind of research. We are doing something called quantitative research, quantities. So we take everything about you, humans, attitudes, beliefs, all this kind of fuzzy stuff, and we measure it in a way that gives us a number, because then we can do statistics, and that's just the kind of research we're doing. So we need to know something about statistics. Now, hopefully you guys are going to have to take some kind of statistics course. This will sort of lay a foundation. It's really not about math. It's about logic. It's about how we make decisions. So it's not that weird. You make decisions all the time. You guys can get this. It's pretty basic stuff, and it's really going to help lay the foundation for you guys as you move forward in your psychology classes and understand how researchers are making decisions. Because we're trying to make right decisions. We don't want to screw this stuff up. So let me throw some PowerPoint slides up here to kind of help us keep on track and, so you know what I'm talking about. All right, so we need some data. Let's start off. Here's some data. I asked 5 high school students, what is their annual income? And here's what I got. Now, right now it's a bit of a mess, and I'd like to kind of organize it. So I think the first thing I'll do is put them all in order. Okay, that's better. So, we got a couple of people that just kind of, they don't do anything. $50, I don't know, maybe that guy did an odd job. This is earned income too, not birthday presents or something. So he did a couple odd jobs or something. 125, maybe that person did a little babysitting. 1,200, maybe that person had a part-time job for 1 semester. So we got some income. Now, if I want to go further and describe this data set and kind of understand it, what might be something I could calculate? Think if you take an exam and want to go, okay, I want to understand how the class did. What might I calculate? We'll go, well, what about an average score? Well, that's good. Averages are also called means. Mean score, average score, same thing. So the mean income of these 5 students is $275 a year. Now, notice that if I ask these students, hey, raise your hand if you think 275 is, kind of more or less what you make. Probably nobody would raise their hand. So that's not uncommon. You have an average, which it doesn't even, that score itself doesn't exist in my data set. It gives you a mean, but no one actually makes that. That's kind of interesting. Now, there are a couple other descriptive stats I want you to know about this. Got the mean, you're probably pretty familiar with that. There's also this thing called the median score, the middle score. And that's honestly just what's in the middle. Now, we have an odd number of data points. So you can kind of count in and go, what's the middle score? It's 50. That means half the scores fall above this number, half fall below. That gives us a little more information. Since averages can be kind of funny, a median score is often really helpful. Like if you want to know about really, people's income, or, what do people spend when they buy houses, or da-da-da. If you have an average, there's some people that can be kind of skewing that average because they make a lot or they have these really fancy, expensive houses. So sometimes it's better to say, oh, the median house price or the median salary, the middle. And then I know, oh, half the people make more, make less. Half the houses are worth more or less. It's a nice one. Then the last one is the mode. It's just what's the most common score in your data set? Well, for us, it's 0. It's possible you might not have a mode if you never have a score that's repeated, but often there's a mode. And sometimes that's interesting to know. Now, these 3 things are called measures of central tendency. And what that means is if these 3 things are exactly the same number or really, really close, what that tells us is we have a symmetrical distribution of scores. So here's a normal curve. And the thing is, a lot of stuff that we measure in psychology is normally distributed. So if I went out and I got the data for everybody's GPA, there's going to be an average score that's kind of in the middle, or an average score, and then there's going to be some people above it, some people below it, and if I get enough data points, like a few thousand data points, I'm going to, and I graph them, I'm going to see this really nice, pretty symmetrical normal curve. It's going to work for height. It's probably going to work for attitudes. I have to look into that. But a lot of things we measure about people, you get a bunch of people in the middle of the distribution. You got some on either end, either tail, the extremes, and you get this sort of nice curve. And this is really good for us because there's some properties about this normal curve that allow us to do certain statistics and make certain assumptions. But all I really, for this level of class, what we want you to understand is mean, median, mode are measures of central tendency, and they tell us something about the symmetry of this curve. Okay, that's kind of all we're going for right now. All right, now let's look what happens if we add sort of an unusual score to our data set. We had the superintendent of this high school system come in and go, what's your score? Oh, he makes $200,000 a year. Wow. Now, an outlier is any score that's just sort of way off from the rest of the pack. I mean, there's all these guys, and then there's this guy way out here. Or it could be on the low end. There are all these people, and then there's the score that's kind of hanging out down here on its own. And I want to see what that does to our three measures of central tendency. Let's get a new average. Well, our average was $275, right? Look at it now, $33,562. Oh, now if you go, hey guys, raise your hand if this describes you. Nobody's like, oh. 5 of the people are like, wow, that'd be awesome. And one guy's like, oh, you're crazy. So we really have a mean. And I want you to notice outliers can have a big impact on the mean. The mean is very sensitive to outliers, and it really whacks it out when you have this score that's just unusual in your data set. But what happens to our 2 other measures of central tendency? Let's look at the median, the middle score. Well, now that we have an even number, we can't just count in and go, what's the odd guy in the number? So we look at the 250 and 125, the middle score somewhere in between them. So actually, I just take an average of those 2. I say, well, what's the score right in between these? It's 87.5. So again, here's a score that doesn't even exist in my data set. But what that tells me is half the people in my data set scored higher than 87.5, half of them scored lower. So it's still a pretty useful thing to know. What happened to my mode? Nothing, still 0. So the mean is very sensitive. It can get whacked out by an outlier, usually does. And the median and the mode, median changes a little bit. It's not a huge difference. Mode didn't change at all. So the median and mode are less affected. They still can be affected, but not as much as that average that just goes, wow. Okay. All right, so these describe the symmetry of my curve. Now there's some other things. Oh, yeah, here we go. Just to remind you, some other things. Now I want to know, well, how much variability do I have in my data set? Basically, how different are the scores from each other in this group? Okay, how much do they spread out? Because I have this average score, but are they really close to the average, or are they kind of all over the place, and that average is just this, thing? And there are a couple of measures we can do. The first one is called the range. This is what's the range of score? Well, if you take the highest minus the lowest, you get the range. It's 1,200. So I have this score, this data set of incomes, and someone says, well, what's the range of income of the high school students in your sample? $1,200. Okay. And I throw in that outlier, of course. What's my range now? $200,000. Range it's kind of interesting. It's a little bit limited in what it tells us. Now, the next measure of variability is something that you probably have been ignoring, and you shouldn't, because it's really important. It tells you some really good information about data sets. It's called the standard deviation. Okay, the standard deviation. Here, look at this definition I have. I want you to really think about it and just, let it soak into your head and really love that definition. Oh, I wrote it, wrote it funny. All right, so what my slide should say is, on average, not how average, on average, how far the scores fall from the mean. All right, so let's look at this. Okay, let me see. Actually, let's go up to this this little normal curve thing here. Okay, let's look at this. And let me get a little mouse to show you. Okay, so you can see my mouse now, right? So here's my average score. And ignore these numbers down here. It just has to do with standard deviation. Here's my average score, whatever it is. Let's say it's 512. And let's see and look at the score that's here. Whatever this score is. This point here where my arrow is. It's this far from the mean, right? It's a little bit above it. Okay. The score that's represented here on the graph, a higher score, it's this far from the mean. It's farther, right? Score up here is even farther away. Look at the distance from the mean. That's what I'm looking at, distance from the mean. Go over here. This score right here, whatever it is, it's this distance from the mean. This score is this distance from the mean. It's really far. The score that's here, it's just a little bit away from the mean. So basically, I have all these distances from the mean, that every score in my data set is a little bit, it's close or it's far, and I take all those distances and I average them. It's pretty much what it is. And so that gives me the average distance from the mean. That's what the standard deviation should say. So ignore my slide here and say, standard deviation, it's the average distance that scores fall from the mean. Okay. Now, the way you'll have seen it or maybe recognize this, it's when you see data and it goes, plus or minus. So it says, well, the average score is this, plus or minus this. And that tells you, on either side, most people are kind of within this range. Now, for this initial data set, the standard deviation for these 5 scores was $519. So we had an average for these 5 scores of $275 average income. And we go, plus or minus $519. Now, let's look at what that means. Look at this curve here. Here's our normal distribution. The thing about normal distributions is they have a pretty cool thing. 68% of the scores in the data set will fall within one standard deviation. So one standard deviation above, oops, hang on. Here's our mean, see my arrow? One standard deviation above is all scores from the mean up to this score, whatever it is. And one standard deviation below the mean is all the scores that fall down to here. Now, that's the thing about these perfectly symmetrical normal curves, is that this is a property of them. And every curve that's like this, 68% of your scores are going to fall within one standard deviation above or below the mean. Okay, that's really cool. And then if you want to know, if you go 2 standard deviations, it's like, check your book, it's like 96% of the scores, 95, 96, I forget. And if it's 3 standard deviations, it's like 98% of the scores in your set will fall within 3 standard deviations. But let's just think about this one here, all right? 68% of the scores fall within that. All right, so now what standard deviation is basically telling us, if it's the average distance from the mean, here, look at me at this little window, then it's telling us how skinny or wide is our curve. Because if we have a big standard deviation, we're going to have a wide curve because scores are falling far from the mean. If we have a small standard deviation, we're going to have a little skinny curve because the scores are really close to the mean, right? So if you look at this curve here versus this one below it, which one has the smaller standard deviation? It's this one here because it's skinnier. Scores are falling closer to the mean. Look at these guys. Now, they don't have to be shorter. These pictures do make them look shorter, but they don't need to be. But look at what curve here has the largest standard deviation? It's the widest. The scores fall the farthest from the mean. Well, I guess it'd be this guy down here. He's really wide. He could still be tall if he wanted to. I don't know why they drew it like this, but he's just like, scores are really spread out. Okay. So this is why you guys are going to love standard deviation as you move forward in your classes and in life, because you're going to take a class, and you're going to take a test, and it's going to say your score is 73. Okay, X stands for one score. And you're going to go, ooh, 73, oh my goodness. And you're going to look on Blackboard and go, what was the average score? I want to know. What was the average, right? What was the mean? The average score, now I couldn't find the symbol, but the mean is always denoted by an X with a little bar across the top. I could not find that X bar in my symbols, so I wrote X bar. But that just means there's, okay. And you look on Blackboard, or the professor says, oh, well, the average score was 76. And you're like, oh, I'm below average. Guess what? You shouldn't be upset yet because you don't really know how you did yet. The mean is not enough information. What you really need is the standard deviation. You need to know, well, what did people do? Is the mean a really good description and people were all around the mean, or were scores like all over the place and the mean doesn't really mean that much? All right, so let's look at this. What if the standard deviation of this exam you took was 10? Okay, so remember, it's the plus or minus. It's like, well, the average score was 76, plus or minus 10. What that means is 68% of the class scored between a 66 and an 86, right? Between 66 and 86, you know, big, huge chunk of the class, almost 70%, but it's 68% of the class would have gotten between that. So now you're thinking like, well, hey, 73 is not really that bad. I'm kind of right in the middle of the pack. You know, I didn't do horrible. It's not so bad. All right, let's run another scenario. Let's say the professor goes, well, the average score was 76, and the standard deviation was 2. Now what does it mean? Well, now the pack just got a lot skinnier, didn't it? Now it means 68% of the class got what? It got between a 74 and a 78, right? Because that's the plus or minus. From below to above the mean. 74 to 78 is 2 below to 2 above. So 68% of the class got somewhere between a 74 and 78, and you got a 73. Now you can be upset. Now you can be like, oh, gosh, I didn't do so good, did I? Oh. Now, let's say you got a 78 was your score. And actually, let's make it something different. What if on this test you got an 80, and you go, the average score was a 76, same average, and you got an 80, and you're like, woohoo! Now hold on, standard deviation of 10. That means 68% of the people got between 66 and an 86, and you got an 80. All right, so you did fine, but you're just kind of right in the middle of the pack, you know. As opposed to standard deviation of 2, 68% of the people got between a 74 and a 78, and you got an 80. Okay, now you're special. Now you're like, woohoo! I'm like outside the pack. I'm like, woo, way up. I'm an outlier, almost. I'm just woo, doing awesome. Okay, so I hope you understand how important standard deviation means to understand where your score fits in the grand scheme of things. Okay, and again, this is a measure of variability. Let's get my slides back. All right, tells me where do the scores fall? How do they spread out? Okay, let's keep going here. All right, now that's what I want you to know about descriptive statistics. There's measures of central tendency, there's measures of variability, and it's just describing the numbers you have, your sample, your data set. So I just need to show you quickly kind of graphs, make sure you guys know how to read a graph, and then you're gonna go practice your descriptive stats on that handout. All right, so how do you read a graph? Well, here's a bar graph, pretty common. We saw this earlier in the class. But notice, the independent variable is always on the x-axis, right on the bottom. So this one, now it's not a true IV because I didn't randomly assign you to meet your spouse online or offline, but it's our groups. It's a quasi-experiment. So that's on the bottom of the, our groups that we have. And then on the y-axis is always the dependent variable. What was measured? Well, we measured marital satisfaction, not by asking you, how do you feel about your marriage? Just tell me. Qualitative data. I mean, it's good. It's just something different. I said, on a scale of 1 to 7, how satisfied are you with your marriage? And you circled a number. I was like, okay, I can run stats on that. So there's my dependent variable, marital satisfaction, on the y-axis, the up and down one. All right, here's a different one. This is a line graph, not a bar graph. We can use line graphs when we have continuous variables, meaning, in the bar graph, there's just categories. Line graph, there's things that it actually goes along a continuum. Time has infinite, there's no spaces in there. It's just like it continues. Now, this one, I want to use my arrow again. Let me find my arrow. Okay. This one here's time in minutes. I basically was taking people's heart rate, Mabel and Albert, okay, two participants. I was taking their heart rate at this time this time, this time. So there were 5 time points where I measured their heart rate. Now, look between time 1 and time 2, and we don't, it's minutes, but they don't tell us how many minutes. In between these 2 measures, I didn't actually measure their heart rate, but their heart was still going. This is while they're exercising, I guess. It's not like it stopped, right? There really is something in between here. And it's probably, we could probably expect that it gradually increase. So by drawing this line, I am sort of making the assumption that between this time point and this time point, the heart rate gradually sped up. It didn't just jump from one to the other. So by drawing these lines in here, there's 2 things. First of all, we know there's something in between. There really was heart rate in between these 2 measures. The heart was going. And I'm kind of inferring that probably, maybe it was a gradual increase, decrease. So I can do this with this kind of variable that's continuous. It goes on a continuum. I don't know how else to say it. And this is the number of beats that I measured. So my dependent variables here, my measured variables here. All right, here's another graph, another bar graph. Now this is for categorical data, okay? So I have different kinds of fertilizer that I'm using. That's my independent variable. And there's nothing in between them. There's Miracle-Gro and there's fertilizer from Kmart. There's nothing in between. So I can't draw a line graph because that doesn't make sense. There's no in between there. These are categories. You got one of these fertilizers and you didn't get the others. Here's look, a control group, no fertilizer. So basically I can randomly assign these plants to get certain kind of fertilizer or nothing. That's my control group. How many levels of my independent variable do I have here? 5. There are 5 categories. And then I measured their growth, average height in centimeters. That probably means I had multiple plants in each category as participants, And then I measured all those individual plants and averaged them for each category, and I've graphed them. Look at the title of the graph. This is, from the title of the graph, you can identify the IV and the DV, right? Because the IV, independent variables, is the thing that affects the dependent variable. And the dependent variable is measured later. So the effect of, the effect of fertilizer on bean plant growth. So the effect of that fertilizers have on growth. So I'm measuring growth. The fertilizer is going to come first. I'm going to measure growth later. And depending on which fertilizer you get, it should affect how tall you grow. IVs affect DVs, right? So I decide which fertilizer you get, independent variable. I'm a researcher and I'm an independent person. I get to choose what fertilizer you get. And then later on down the road, I measure growth, and I do that across all my categories. Everybody gets measured and how tall they are, right? You probably are good at graphs, but just to make sure. All right, so at this point, let me stop sharing this slide. I'm gonna say go do that descriptive stats sheet, practice sheet. Do not look at the answers until you try it. Oh, your book in the appendix, I tell you the pages to go look, and it has a lot of detail in that appendix, but which we probably won't need. You're not going to have to calculate this stuff. I do make you calculate an average on one sheet, but you know how to do that, right? Add them all up, divide by the number of scores you have. So go ahead, do that descriptive thing, learn it, love it, and then you'll be ready to move on with the next video segment.